Hey, so hello everyone. Yeah, I think I am live, right? Okay. So hello everyone. I think now I am live. Okay. So we will discuss something new things here. Some announcements. So I'm just waiting for some people. Let them join. Then we can start. Okay. Yeah. And is my voice is audible? Am I audible? You can tell in the comment box yes or no. Then I can proceed. Yeah. So let me share the link. Okay. Then we will start. I'm just waiting for some more people, so then we can start quickly. Okay. Yeah. Okay, fine. I think uh, yeah, so I'm just waiting for some more people to join and then I can start. Yeah. So can you tell me, am I audible or not? Am I audible? Yeah, I am just waiting for some people to get joined and then we can start very quickly. Okay. And we have done actually this is my first live. Okay, so we have done first live in the afternoon, right? Yeah, in the afternoon we have done first session, live session, and we are going to do again live. Okay. Yeah, I'm quite excited to going on live. Okay. uh, I think now I am addicted to going live. Yeah. Yeah. So I'm just waiting for some more people to join. I have shared the links in the organic chemistry groups. So let them join, then we can proceed. Okay. Yeah. We are just waiting. Okay, so I think 5 people are here. So, okay, RM Kesri, good morning, sir. Okay, good morning, and chemistry with Karan. Yeah, so hello Karan, how are you? I hope you are all doing well. Swarna Lata Sonkar, hello Sunansu. Hello Swarna, hello Aryan, hello Karan. I hope you are all doing well. So, yeah, so 10 more people have joined now. So Pratna, he should answer. Yeah. Hello Pratna. I hope you are all doing very well. Actually, I have decided. Oh, link milega. Yeah, of course. I will give you your link. Huh? Muhammad Sudur. Yeah, of course, Muhammad. We will do. We will together. Okay. We will do together. Right. Rahul, hello, bro. Yeah, hello, Rahul. Actually, I have just installed the Wi-Fi, so I am telling you, like, to use the Wi-Fi very efficiently. I think this is the best method, right? I think this is the best method to use this Wi-Fi. So because the cost of a Wi-Fi per month is 700, so I have to use. So I have to utilize this. So that's why I have thought to start a Clayden organic chemistry series in which we will solve questions of the organic chemistry Clayden chapter by chapter. Okay. So in this session today we will talk about chapter number 6, nucleophilic addition to the carbonyl group. Okay, Hani Tyagi. Yeah, I know you are senior from me. Actually, Hani Tyagi is doing PhD from IIT Delhi. So thank you so much for always encouraging me and supporting me. Sweta Thakur, okay, hi, hello. So hello everyone. So now I think we have to start. Okay. So basically, in this session we will start chapter number 6, organic chemistry Clayden, nucleophilic addition to the carbonyl group. Okay. So we will solve all the questions. Okay. Because in that way we will learn the concepts of the organic chemistry by the help of us solving the questions. Okay. Rather than going to the theory part, right? So I will try to explain all the steps mechanism, step by step. Okay, the reason behind the mechanism, I will try my best to explain. Okay, so now let's start. So question number 1, we are taking from chapter number 6. You can refer. So the first question is, because I know this is a very basic chapter, but still we have to do it. Okay, so we have a reagent here, NaCN and H2SO4. Okay, fine. And here is a H2O as a solvent, right? So what happened? So first of all, you have to see the reagent. Okay, what is the work of a reagent? Okay, so what happened here? This is the Na plus basically. So let me, yeah. So this is the Na plus basically, and this is a Cn minus. Okay. Yeah. And you all know that this Cn minus is a nucleophile, right? And here in this substrate, we have taken here acetone, and this C double bond O group is working as an electrophilic center. Yeah, I know this is all basic things, but still I have to tell. Okay, so why this is a electrophilic? So you have to understand here, because C double bond O, and due to electronegativity difference of this oxygen and this carbon, so you will get here delta negative charge and you will get here delta positive charge. Okay, so that's why this bond, this pi bond will be polarized, and this carbon center is acting as an electrophilic center. Okay, electrophilic center. And you all know that in the organic chemistry, the reaction happens between the electron rich to electron deficient center, as you all know this. Okay, I know. So now what happened, what you have to do here? So see, we have here carbonyl, and you all know this carbonyl is a electrophilic center, so that's why the Cn minus is a nucleophile and will attack on this electrophilic center, and then the pi bond will be gonna shift in this on the oxygen as a negative charge, and you will find something like this O minus here. Okay, and here is a cyanide, right? And you all know that and you all know, if I leave this reaction up to here, then what happened? Then again this O minus will gonna come back, and this Cn minus will be leave as a leaving group. But this reaction will be gonna reversible. But I am doing this reaction to get some product, to get some efficient product. So that's why we have to do something here. We have to work up, so that we can get an actual product. Okay, to stop the reversibility, we have to do here workup. Okay, so how can we do the workup? So take the H plus here, right? And then this O minus will take this proton, and then you will gonna find something like this OH here, and this is a cyanide. Okay, so many people can ask why we are doing here protonation. So the reason behind this protonation, and if we leave this as it is, like, okay, so then what happened? This O minus again gonna come back, and then this Cn minus will gonna leave, and then we again got this product as a substrate and the same substrate. Okay, but we have to do some reaction. We have to do some efficient reaction. We are doing this reaction because we have to get some product. So that's why in the last step we have to do a workup, okay, to stop the reaction at this stage. So that's why, okay, so Aryan is saying that दिख नहीं रहा है. Is it? Okay, red pen is not visible. Okay, sorry. So let me use the something different color. Okay, fine. So now you will get this product. Now this is visible. Am I audible or not? Okay, okay, fine. Yeah. Okay, so see, so now what happens? So this is the product. Okay, so this is the product of the first question. We have taken here carbonyl, we have taken here reagent NaCl H2SO4, and H2SO4 is an acidic condition to do the workup. Okay, but the main thing is here. Now I am moving to next question. Now see the second question is a more interesting here. Okay, the second question is, I think I have to use the yellow color so that it will be more visible to all of you. Okay, so here we have question like this. Nitrogen here, C double bond O, NaCN, and here H2O. Okay, so someone is asking that why the nitrogen did not attack, why the carbon side attack on the CO. Okay, so the reason is basically the carbon is a more good nucleophile than the nitrogen. If you move from left to right in the table, in the periodic table, carbon, nitrogen, oxygen, or a fluorine, okay, so you will get something. This carbon is a more nucleophilic than nitrogen, and then oxygen, and then fluorine. It means if you go to left to right, the nucleophilicity will gonna decreases. Okay, I think this is a very base. Yeah, you have asked the question. That's a very good thing, because these all things like which is a more nucleophilic, which is a less nucleophilic, these all we have to study in the GOC part, general organic chemistry. Okay, but I have still I am still telling you the carbon is a more good nucleophile than nitrogen. So that's why the NaCN minus, the carbon is attacking on this carbonyl, because due to carbon is a more good nucleophile. Okay, I think the doubt is clear now. Yeah, so now move to the next question. I have to erase this one. Okay, yeah, so here Keshav Sharma, yeah, hello. Tanuj Hakkar, hello Tanuj. Nitrogen is a more electronegative, so it will have negative charge. But you have to attack the electrophilic position. In the organic chemistry, you have to always see the most electron rich and most electron deficient. So that's why in the cyanide, Cn minus, the carbon is a more good nucleophile than nitrogen. So that's why the carbon is attacking on the carbonyl center. Okay. Yeah, so don't use red color. Okay, yeah, of course. So now we move to the next question. So this is our question here. So we have taken, this is our substrate, right? And now this again is Na plus and Cn minus, and Cn minus is a nucleophile, as we all know that. And this C double bond O is working as a electrophilic center. So that's why this Cn minus will attack on this electrophilic center, and then this pi bond will gonna shift on the oxygen, and you will gonna something like this. I know this is very basic, but still I have to do. Okay, good. Sorry. Someone says that I don't have to use the yellow, red color. Sorry about that. Yeah. So you will get something like this. Nitrogen here, O minus, and here cyanide, right? And we have taken here H2O. So what happened? This you can do here. This O minus will take proton from this H2O, and then you will get something like this. I know this is very simple, but still you have to do, because in the organic chemistry you have to move the arrow, then you can fill the organic chemistry. Okay, yeah. So this is a product, right? Dark karo thoda. Okay, so how can I make it dark? I think I have to use the. Now it's visible or not? Yellow color is visible or not? Please tell me. So can I make more zoom? Okay. It's visible. Oh, sir. It should be visible. I don't know why. Okay, this will be gonna nightmare for me. Yeah, I will try my best. Okay. So for today, just compromise. I know, but still, let me check what I can do. Now it's visible. Now it's visible or not? Just tell me. Okay. Now it is visible. Okay, fine. Yeah. So now we are moving to next question. Yeah. So basically we have, I know these are all the basic questions, but still I have to do. So here we have taken aldehyde here, and NaCN here, and here you have H plus. Yeah. So again, this Cn minus and this is Na plus. So Cn minus will act as a nucleophile. Okay. So this Cn minus will attack on this electrophilic center, and now you will gonna find something like this. OPH here is the O minus, here is the H, here is the cyanide, and after you have to do workup here H plus, and this O minus will take proton, and then you will gonna find something like this. Here is the OH, here is the H, here is the cyanide. Okay, yeah, fine. So now move to next question, fourth question. I think I have to skip the same variety of the question, okay, so that I can complete the session very efficiently. Okay, fine. So now I am taking something different. This is a more conceptual. Here is a C double bond O, here is the Me, here is the Me, right? And I am taking here is a H minus, only H minus. Now you tell me, what is the product what is the product you will get from this reaction. So basically, here we have taken in the reagent H minus. Okay, so I think most of all you know, like H minus is a strong base. H minus is a strong base. Like you can take a NaH, sodium hydride. Okay, so this is also a strong base. So this H minus will not gonna do attack on this. This is wrong. This is wrong mechanism. Okay, you can't do attack H minus as a nucleophilic attack on this electrophilic center. If you do this, this is totally wrong. Okay, so what is the correct? So basically this H minus will work as a base. Okay, right. So now what happened, suppose you have taken your H minus, I am taking different example, and you have your HX type something like this, and then this H minus will work as a base, and this base will take proton, this hydrogen, and now you will gonna find, now you will get something like this, H2 plus X minus. Okay, so basically if you do this, if you do attack of the H minus at the carbonyl center, it will gonna be wrong. It will act as a base. Okay, so in the actual, you have to, the right mechanism is, here is a CH3. Okay, so this H minus will take proton from this carbon, because this H is more acidic proton, so that's why you will find some enol. Okay, you will find enolate ion, right? So this is a CH2 minus, and this minus will be gonna delocalize, and now after that you will find enolate. So you have to pay attention. Okay, what I am trying to say, the H minus will not work as a nucleophile in the case of a carbonyl. It will work as a base. H minus will always work as a base, right? It will take the most acidic proton. Now move to fifth question. Sorry. So this is a more interesting. Okay, so suppose this is our carbonyl here, H R, and I am taking NaBH4. Okay, NaBH4. Yeah. So just simplify the structure of the NaBH4. So this is the BH4. Okay, and here is a negative charge. Now what happened? Yeah. So because this is our electrophilic center, okay, and so that's why this H minus will gonna leave. H minus will gonna leave and act as a nucleophile and will attack at this carbonyl center. Okay. Okay, someone is asking question, in the cyclopentanone and the cyclohexanone, which will react fast with HCN and why? Okay, and the next question is, sir, H minus is soft in nature and carbon center is a soft center, then why would not be this? Then why would not be this attack happen? Okay, so basically H minus is a base. Okay, I am assuming that H minus is soft, but here is a no possibility. Like suppose here we have something like this, then we can think about it will attack on this position or it will attack on this position. Then we're gonna think about this. But here we have taken, we have only one possibility, that we have carbonyl center. Okay, and we know that this H minus will always work as a base. It will not work as a nucleophile. It is a strong base like a NaH, sodium hydride, so it will take a proton rather than nucleophilic addition. Okay. So let me erase this. and now so this H minus will attack on this carbonyl, and now you will find something like this O minus here, and here is a R, and here is a hydrogen. Okay. Now we have BH3 is left here. Okay, and this because boron has a vacant orbital, so that's why this O minus will attack in this boron vacant orbital. Now you will find something like this. HO, here is a boron, hydrogen here is a hydrogen, okay, and you will get a negative charge here, right? You have here R, here is a H, okay, fine. So now what happened? Yeah, see, now we have to do workup. This H plus, this O lone pair will take proton, and now you will find something like this. HO, BH, here is a H, here is a H, and here you have something like this. R here, here is the H, and the oxygen got a positive charge. Okay, so to make and neutralize this oxygen, we have to break the bond, and this will bond gonna break something like this. And here is a negative charge, of course, and now you will get alcohol here after the reduction. Okay, after the reduction you will get this BH3. Okay, so now after the further, because we have a still BH3, and you know that BH3 is a reducing agent, so it can reduce the more molecules. Okay, but I am stopping till here. Okay, right? You can because this BH3 has 3 hydrides, 3 H still, so it can reduce 3 more molecules of ketone or aldehyde, as you can take in this reaction. Okay, so one more question in the comment box. In the question, in the comparison of cycloheptanone and cyclohexanone. Yeah, so basically if you take a cycloheptanone and if you take a cyclohexanone, okay, and I am taking here NaCN, so if we have to compare the rate, so Cn minus will gonna attack on this one, and here is also this one. But the question is, which will gonna attack fast? If we have to compare, suppose this is A, this is B. Now if we have to compare the rate, then of course Cn minus attack fast on the 5-member ring. Okay, because in the 5-member ring there is a less alkyl groups in the ring, so that's why this C double bond O is a more electrophilic in the case of a 5-member ring instead of the 6-member ring. So that's why the Cn minus will attack fastly in the 5-member ring in the comparison of 6-member ring. Okay, I hope this doubt will be clear now. Yeah, of course, I will complete the whole Clayden because I have studied the Clayden up to 2 or 3 times. Okay, so I am doing this because I have to also revise. Okay, it means अगर मैं इसे कर रहा हूँ तो इससे मेरा भी रिवाइज हो रहा है. Already I have revised 2 to 3 times Clayden, but to share the knowledge जितना भी हम बढ़ाते हैं, जितना भी हम शेयर करते हैं, उससे नॉलेज हमारी उतना ही इंक्रीज होती है. इट मीन्स sharing the knowledge is directly proportional to gain in knowledge. Okay, so you must have to remember this, right? Yeah. So now we move to the next question. We have I am taking a different variety of the question, so I will not do the same question, the same variety of question. I will have to change the question. Okay. So now I am taking some different. Suppose, yeah, we have something like this: RC double bond O. Here is a H, and I am taking here MELI and THF, and here in the second step we have taken H2O, right? So basically MELI, right? MELI. So this is basically positive, this is basically negative, right? And this Me minus will work as a nucleophile. Okay. Yeah. So now, as you know that this is our electrophilic center, so that's why what happened, this Me minus will attack on this electrophilic center, and now this pi bond will gonna shift on the oxygen as a negative charge, and you will gonna get something like this. Here is the Me, and after that we have taken H2O to do the workup. So what happened here? We have oxygen here, we have oxygen, we have H2, and this O minus will take proton from this H2O, and now you will get something like this. OH, here is the H, here is the Me, and this is your final product of this reaction. Yeah. Okay. So basically, these are all the nucleophilic addition. It means this Me will do addition on this carbonyl group. Okay. Now I am taking some different examples, the same variety but it's a little bit different. RC double bond OH. I have taken here PHLI, and THF has a solvent. Okay, and we have in the second step H2O. The same mechanism will be followed here again. So PHLI means, let me draw the structure. It means something like this. Minus, here is a positive. Okay, so PHLI, the pH minus will work as a nucleophile. You know this. So what happened? So this is a negative charge, and this negative charge will attack on this electrophilic center, carbonyl. And now you will gonna find something like this. O minus here, here is the H, here is the pH, and now after that, because we have taken here H2O, so we have to do workup. So this O minus will take proton from this H2O, and now you will gonna find something like this. OH here, here is a pH, and this is our final product. Okay. Now I am going to take some different question. सर थोड़ा ब्राइटनेस बढ़ाइए. How can I increase the brightness? How can I increase this brightness? Huh? Okay, Angel Rana. Okay, yeah, I'm trying my best. I think a screen is visible or not? Please tell me. Yes or no? Aryan Kesri. Yeah, I know. Aryan, you are doing integrated PhD from ISC Bangalore, and congratulations for this, for your success. Okay. Yeah, I think I don't know what is the problem. It looks like dark jungle. Okay, Bhumika. Okay, fine. Yeah, nice to meet you. Yeah, of course. I think you have to increase the brightness. Okay, because here I have done the full brightness. You can see I have done the full brightness. I cannot increase. Okay, Vavo. Okay, yeah, Vavo is my friend. Nice to meet you, Vavo. Thank you for joining the session. Yeah, so thank you for all of you for joining the session. But still, I have left some questions. I have to do it. Okay, so now I am taking some different questions. So question number, yeah, I forgot the question number, but still I am putting the hash mark. Okay. So now we are seeing this RC double bond OH here, pH MgBr. Okay, in the second step we are taking H2O. Okay, so pH MgBr, it means pH here minus and Mg plus, and here is a Br. And you all know this pH MgBr is a Grignard reagent. Okay, so that's why. And if you have carbonyl group, okay, if you have carbonyl group, then the Grignard reagent will act as a nucleophile. Okay, but there is some more cases in which Grignard reagent will work as a base also. If in the substrate, if there is an acidic proton, if there is a most acidic proton available in the substrate, then the Grignard reagent will act as a also base also, right? But in this case, the pH MgBr will work as a nucleophile, so that's why this pH minus will attack on this C double bond O, and now you will gonna something fine. And I am requesting to all of you, please increase your brightness so that you can see very clearly, because I cannot increase my brightness, okay, because I am using at the full brightness. Now I cannot increase more. Okay. Now this pH minus will attack on this carbonyl, so now you will gonna something like this, and here is a pH, and after this you have to do here is a MgBr, because Mg plus is a this is a counter ion, Mg plus, so this O minus will coordinate this with this Mg. Okay, now after we have done here workup, and after this workup, this O minus will abstract the proton, and then this will become OH, right? And this is our final product. I know office का light on कर दो. Nikhil Singh, hello sir. Yeah, hello Nikhil, hello Muskan Agrawal, hello Vaibhav, hello Angel Rana. Yeah, thank you for joining me this live session. I cannot expect so much student will come to join this session, but I am very happy. Yeah, I am trying my best, okay, as much as possible. Sorry. So please tell me now, a screen is visible or not, sufficient brightness or not. Okay, so now I am taking some interesting question. Yeah. RC double bond O, here is the H. Okay. Now I am taking ETOH. Okay. ETOH. Only ETOH. So now what happened? This ETOH is working as a nucleophile. Because oxygen has a lone pair, so that's why this ETOH will work as a nucleophile. And then what happened? This oxygen lone pair will attack on this electrophilic center carbonyl. And now you will gonna find something like this, O minus here is a hydrogen, and here is a ET, and here is a H, and of course you will get a positive charge on the oxygen. Okay, and after that there will be proton exchange will be happen. It means this because oxygen has a positive charge, and we know that the positive charge on the oxygen is not stable, so that's why there will be intramolecular proton exchange transfer will be happen. So how this will happen? This O minus will take proton, this proton, and now you will gonna find something like this. Here is the OH, and here is the H, and here is the OET, right? Okay. So now what happened? So this is our product, but this product is a reversible. Okay, this product is a reversible. It means RC double bond OH is a reversible. If we take here ETOH, if you take ETOH as a reagent, then you got a reversible product, that is a ROH here, and here is a OET, right? Because this OH lone pair will again gonna come back, and this OET minus will gonna leave. So that's why this reaction is a reversible reaction. Okay. Now see the next question, some more interesting. Okay. Yeah. So something like this, we have taken OH here, double bond O, here is the H, and you all know that what will gonna be happen. यहाँ पे अब क्या होगा, because oxygen has a lone pair, so that's why, and in the same molecule this work as a nucleophile, and in this molecule this will work as an electrophile. So that's why in the same molecule we have a nucleophile also, we have a electrophile also, right? So what happened now, because now here intramolecular reaction will be happen. Intramolecular reaction will be happen, and now after that you will get something like this. This OH, see, this OH lone pair will gonna attack on this carbonyl center, and this double bond will be gonna shift on the oxygen as a negative charge, and now you will find something like this. Here is the H, right, and this is O minus, here is the H, here is the H, and of course oxygen has a 3 bonds, so that's why it will be positive charge. And because oxygen पे आ गया positive charge, and we know that the positive charge on oxygen is not stable, so that's why we have to make it stable. Now how can we make this stable? Because we have in the same molecule we have a O minus, and this O minus will work as a base, and this O minus will take a proton from this oxygen. Now this bond will gonna break, and now this oxygen positive charge will gonna neutralize. Yeah, of course, Wavo, I will make a playlist. Okay, don't worry about that. Okay. So now you will get. So this is basically intramolecular proton transfer. Okay, proton transfer. So now you will get something like this. Here is the O, and here is the OH, and this is called cyclic hemiacetal. Cyclic hemiacetal. Right? This is called cyclic hemiacetal. I hope you all know this. Okay. Yeah, sorry. And now see the next question, that is very interesting. Yeah. Suppose we have something like this. Here is the OH, double bond O. Here is the H, OH here, and here is also OH, and here is also OH. And I can rearrange this and write in a different form, something like this. Okay, I can write this molecule in this form also, so to make the simplicity, so that you can understand very clearly. Okay, so double bond here. Sorry. So here is the OH at the equatorial, you know that. Yeah. So, and this is our OH. Now what happened? Because same cases also here, because this is a nucleophilic, this is a electrophilic center due to carbonyl, due to electronegativity difference. This carbon has a delta positive and here it has a delta negative. Okay, so that's why let me check the streaming is going well or not. Just let me check. Yeah, the streaming is going fine. Okay, fine. Yeah. So now what happened? This carbonyl is a electrophilic center, and we have in the same molecule we have a nucleophile. So that's why what happened? This nucleophile, this OH is working as a nucleophile. Okay, so that's why it will attack on this electrophilic center, and now this double bond will gonna shift on the oxygen as a negative charge. Okay, so you will get something like this. Here is oxygen, and this is undefined stereo. Here is the OH. Okay, and here we have OH, and here is also OH here, and here CH2OH, right? Yeah, so this is basically cyclic glucose. This is a cyclic glucose. So you have to understand here, like we have this substrate, we can rearrange this as in this form, and after this we know that in this molecule we have a nucleophile also. This OH is working as a nucleophile, and this C double bond O is working as an electrophile. So that's why this is an intramolecular attack. Intramolecular attack, right? So here what happened? This OH lone pair will attack on this carbonyl, and now you will gonna find something like this O minus, and after the workup you will get cyclic glucose. Now see the next question, the next very important question. Okay, that's a very interesting, right? So something like this, we have here OH, and here OH, this is below the plane, and here C double bond O, here is the H, here is the OH, and I can write this in this form to make more simple, to make more simplicity, so that you can understand. Okay, yeah. So this molecule and this molecule are both same thing. Okay, you have to pay attention. Okay, what I am saying, this molecule and this molecule are same thing. Just I have simplified this molecule into this form, so that you can understand very easily. Okay, so now what happened? Now you know that you can say this oxygen will attack on this position, this oxygen will attack on this position, this oxygen will attack on this position, this oxygen will attack also on this position. there is so much more possibility of attack in this reaction. Suppose this is A, this is B mechanism, this is C pathway, this is D pathway. So which pathway is correct? We have to decide. Okay. So now what happened? As you already know that the 5 member, 6 member, 5 member, then 3 member ring is a more favorable. Okay, more favorable. Okay, in the case of in the organic chemistry, right? So 6 member will be more favorable, and then 5 member, and then 3 member. So we have to decide which oxygen lone pair will attack on this carbonyl so that we can get a stable product. Okay, so let me erase all this arrow. Okay, so now see this oxygen, it means this oxygen will work as a nucleophile here and attack at this carbonyl center, because it will make a 5 member ring, and you know that 5 member ring is a more stable. So how it will attack? This oxygen lone pair will gonna attack on this electrophilic carbonyl center, and the pi bond will gonna shift on this oxygen as a negative charge, and after this we will do a workup. So this O minus will take a proton from this H plus, and now you will find something like this 5 member ring formation here, and this is our final product. The stereo is not defined here because I will talk about the stereochemistry in the stereoselectivity chapter. Okay, so for this now we are only interested in the product. Okay, so this is the OH here, and this is our CH2OH, and this is our final product. Okay, this is our product, right? So this is basically example of a intramolecular nucleophilic addition. It means the nucleophile is present in the same substrate where is the electrophile is also present. This is called intramolecular nucleophilic addition. Okay, so now we move to the next question. That is a very interesting question. Okay, now see something like this. We are taking here a substrate. Here is oxygen here. Yeah, something like this. Double bond O here, and here O. Okay, here CH2, P double bond O, here pH, and here pH group is attached here, and I am taking here which hydroxyl group. Okay, now you have to tell the product. Okay, now you have to tell the product. Now what happened? See, because this carbonyl is work as a electrophilic center, as you all know this. Okay, and this oxygen has a lone pair, so it has an electron density, so it will work as a nucleophile, right? And now what happened? Because the electrophilic center and the nucleophile is present in the same molecule, so that's why here also intramolecular attack, intramolecular nucleophilic addition will be occur. And how does it occur? Now we will see. Okay, so how it will occur. So this oxygen lone pair will gonna basically attack on this carbonyl, and then the double bond of the carbonyl will gonna shift on the oxygen as a negative charge. I know this is very basic, but you have to still but still I have to do this. Okay. So now what happened? You will gonna find something like this. Yeah, this is oxygen here, and this is a O minus here, and P double bond O. Here is a pH. Here is a pH. Okay, and here you have oxygen. So I am joining this oxygen, something like this, and here is a positive charge on the oxygen. Okay, so now what happened? Because now the positive charge on the oxygen is come, and you all know this, the positive charge on the oxygen is not stable, so that's why this O minus will work as a base, and it will take proton from this O minus will take proton, this proton, to make the oxygen as a neutral, to make them more stable. Okay, so now you will see, now you will get something like this. Yeah, you will get something like this, double bond here. Okay, here is the OH. Just wait. Yeah, just wait. So here we have something like this. Okay, and from this position, oxygen, and here we have OH here, and here P double bond O. Here is a pH. Here is a pH. Okay, so this is our, and this is called hemiacetal, right? So this is our final product. Okay, now we are moving to next question. That is very interesting, and this question is very conceptual. Okay, now see, suppose we have RC double bond OH, and the reagent we are taking here ETOH in the presence of acidic medium, okay, H plus, right? Now what will be gonna happen? Okay, see, first of all, you know that here we have taken here acidic medium. Acidic medium means the H plus is present in the solution, right? So, and you all know that in the organic chemistry, the first acid-base reaction will be occur fastly. Okay, because there is a very less activation energy in the case of an acid-base reaction, so that's why the acid-base reaction will be gonna fast in the organic chemistry. So that's why in the first step the acid-base reaction will happen. And how does this happen? The C double bond O, right? And we have here H plus. So this oxygen lone pair will act as a base, and it will take a proton of this H plus. And now you will gonna find something like this. Here is the O and the positive charge on the oxygen. Now see, here is a only RC double bond O. Now here you will get a positive charge on the oxygen. It means now this carbon, now this carbonyl carbon is become more electrophilic. It's become more electrophilic due to protonation on the oxygen. Okay, this is more electrophilic now in the comparison of this substrate, this C double bond O, right? So we have taken here acidic medium to increase the electrophilicity of this carbonyl center, of this carbonyl electrophilic center. Okay, so that's why what happened now. See, in the first step, the oxygen lone pair is gonna take the proton, because we have taken here acidic medium, and you all know that in the acidic medium we have a proton available here, so that's why you will get something like this. And now due to oxygen, due to protonation of the oxygen, now this carbonyl center is become more electrophilic in the comparison of a substrate. Now see what happened. Now we have something like this. Here is a positive charge and here is a hydrogen. And now we have a nucleophile here, ETOH. And you all know that the ETOH is a nucleophile, and we have an electrophilic center here. So that's why this ETOH will attack on this electrophilic center. And this double bond, pi bond, will gonna shift on this oxygen as a negative charge. And now you will gonna find something like this. Here is the OH, here is the H, here is the OET, and now here is a hydrogen. And because oxygen has now 3 bonds, so obvious सी बात है कि ऑक्सीजन में पॉजिटिव चार्ज तो आएगा ही आएगा. Okay. And because we know that the positive charge on oxygen is not stable, so that's why there what happened, the intramolecular proton exchange, intramolecular proton transfer. How does this happen? See here. See. So how does this happen? Suppose we have something like this. OET, here is a positive charge, here is a hydrogen. And we know that the positive charge on oxygen is not stable, so that's why to make a stable, this oxygen lone pair will work as a base, and this oxygen lone pair will take proton. And now the OET will get a neutral. And now you will gonna find something like this. And now this become OH2 plus. And this is hydrogen. Here is the OET. Right? And now you know this. Now you know, because H2O plus is a good limit group. H2O plus is now a good limit group. So that's why it wants to live. But how does it live? And we know that here we have a OET group also. And in the OET we have a lone pair also. So this lone pair will gonna push. This lone pair will gonna come back here, and now this limit group will be leave as a H2O as a neutral. Okay, so now you will find something like this. OET here positive charge, and here hydrogen. Okay, now after that what happened, we have again the ETOH molecule is present in the solution. Okay, because we have a still electrophilic center in this molecule, so that's why the ETOH will again come as a nucleophile, and it will attack on this electrophilic center, this carbonyl, and this double bond will gonna shift on this OET, right? Okay, so you will find something like this. So let me make this here, RC, here is the OET, and here is the H, and here is the OET, and here is a positive charge on the oxygen. Okay, and okay, so after that what will you do? Just deprotonate this, just do the deprotonation, right? And now you will find something like this. Here is the H, here is the OET, here is the OET. Okay, and this is called acetal. This is called acetal. Okay, so this is our product. So if I summarize this in a very short way, then you can find I have taken this carbonyl, okay, and we have taken the reagent here ETOH and H plus. So now because we have taken here acidic condition, so in the acidic condition you will get acetal, okay. So in the summarized way I can say, if you take RC double bond H and if you take here ETOH and in the acidic medium, then you will gonna find, then you will get something like this, OET, OET. Here is a hydrogen. This is a general reaction, okay. This is a general reaction. This is a general reaction. You will get an acetal, right? Now see, if we do the same reaction in the basic medium, then what will happen? See, these are all questions I am taking from Clayden. Clayden chapter number 6, nucleophilic addition to the carbonyl group. Okay, so now I am taking some different example here. In the basic medium, RC double bond O here. Here we have H and we have taken here ETOH, right, and we have taken here base also. Because we are taking this reaction, we are doing this reaction in the basic medium, so that's why suppose I have taken here as a NaOH as a base, right. So what happened? So this is a base and we know that the base work is to take a proton, so that's why this OH minus will take a proton from this ETOH, because this H is a more acidic proton. And now you will get ETO minus, right? And now this ETO minus is a more good nucleophile than ETOH. So what happened here? Here we have ETO minus, and it will attack on this carbonyl center at this electrophilic center, and the double bond will gonna shift and you will get something like this. Here is hydrogen, here is the OET, and yeah, and after that we have to just do workup. Just take a H2O, okay, because this OH minus has taken a proton from this ETOH, and now this OH minus will become, suppose we have OH minus, it has it takes the proton, okay, so it will become simple H2O. So that's why we are using this H2O as a workup. So what will happen? Let's see. Here we have RO minus, here we have OH, here we have OET, okay. So now because we have H2O here, so this O minus will take proton from this H2O, and now you will get something like, just wait, here is a hydrogen and here is the OET and here is the OH. So this is the product you will get in the basic medium, okay. This is called hemiacetal. This is called hemiacetal, right. This is called hemiacetal, okay. So if you take, if you do the reaction of a carbonyl in the presence of ETOH in the acidic medium, then you will find, then you will get acetal. And if you do the same reaction in the basic medium, then you will get hemiacetal, right. Then you will get hemiacetal, okay. Now see the next question. Now see the next question here. Suppose I am taking the different questions of a Clayden here. Amy, double bond here, here is a Me, right? And yeah, so now I am taking here is a reagent, here is a NaHSO3, and the second one is a NaCN, right? Okay, yeah, fine. So what happened now? So first of all, so we have a substrate here, Me, Me, and here we have C double bond O. Here is the Me. And first of all, you have to make a structure of a NaHSO3. So how it looks like? See, A sulfur, double bond O. Here is the OH. Here is the O minus. This is the Na plus, right? This is a HSO3 minus. Okay. Now what happened? This sulfur will gonna attack. This sulfur will be gonna attack on this carbonyl center, because you know that sulfur is a good nucleophile than oxygen. So that's why this sulfur lone pair will gonna attack on this electrophilic center C double bond O. And now you will get something like this. This is the O minus, and this is Me, and this is our sulfur, and you will get something like this. This is the O minus here, okay, and here you will get a positive charge, right? You got a positive charge here, okay, and here of course there is the OH group is also attached, okay. So now what happened? Now see, we have something like this, right? Okay, here is a sulfur, here is a sulfur, and here is a O minus, Na plus, right? And now what happened? This O minus, of course, sulfur got a positive charge, okay. And now what happened? This O minus will take proton. This intramolecularly, this O minus will work as a base, and it will take a acidic proton of this oxygen. Now you will find something like this. So you will find something like this. Me, here is a OH, right? And here is the Me, sulfur, double bond O, and here you have O minus, right? Okay, so now what happened? Now see, now this, because okay, sorry, this is an O minus, okay, because this O minus takes this proton, okay. So after taking the proton of this oxygen, you will get a negative charge on the oxygen, okay, fine. So now what happened? Yeah, see, I have done somewhere mistake, I think. This O minus will take proton, okay. Okay, fine, yeah, nice. So basically, let me erase this. I think I have done somewhere mistake. So let me again analyze this question. Okay, just wait. Yeah, see, so in the first step, the sulfur attacks on this carbonyl, and then after this bond gonna shift on the oxygen as a negative charge. Okay, and then what happened? This oxygen will got a negative charge and the sulfur got a positive charge here. Okay, till now it's fine. Yeah, till now it's fine. Okay, so now what happened? See, this O minus will take proton of this acidic proton of this oxygen hydrogen attached, this proton. Okay, and after you have taken the proton, you will find something like this. Okay, so let me show this again, then you can clearly visualize like what is happening here. Okay, so here is the Me, and here you have sulfur, here you have OH, right? Double bond O here, O minus, Na plus, and now this O minus will take proton, fine, and this bond, of course there is a positive charge already, and then after this O minus has taken this proton, and after that this bond will gonna shift at this position. So you will find something like this. Here is the OH, right? Here is the OH. Okay, just wait. Now you will find something like this. O minus here, S double bond O, S double bond O, and now here is the OH, and here is the Me, and here Me again. Yeah. Now what happened? See. Yeah, so basically now if you take this proton, this oxygen lone pair, this sulfur oxygen, this lone pair will take proton from this oxygen, right? Now you will get something like this. So here you have sulfur, right? O minus, double bond O. Here you have H plus, because this oxygen has takes this proton, and here you have O minus, Me, here is a M. Now what happened? See, because oxygen got a positive charge here, so we have to stabilize, and so that's why we have to do something. So that's why this double bond will be gonna shift on the oxygen, and the sulfur got a positive charge, and the oxygen will be gonna neutral. So you will get something like this: sulfur, oxygen, OH here, double bond, you get a positive charge here, okay, positive charge here, and here you have O minus, here you have Me, here you have Me. Now what happened? Because now the sulfur got a positive charge, it wants to leave, it can leave, and how it can leave? When the O minus charge, when the O minus electron density will gonna come back, and then this bond to electron will gonna break, and it goes on the sulfur as a negative charge, and then the sulfur will become neutral now, and now you will find something like this: Me, double bond here, here is a Me. Now see, I have taken here in the reagent NaCN also in the second step. So now what happened? The Cn minus will come again. The Cn minus will come as a nucleophile, and this will attack at the electrophilic center C double bond O, and this bond will gonna shift on the oxygen as a negative charge, and now you will find something like this. Here is the Me, and here is the cyanide. And now you know that. Now you know that here from this you will get something like this, OH. Here is a O minus. Here is a double bond. Okay. So because this is O minus, so we have to do workup, and how we can do workup. So here we have in the reaction, here is a sulfur OH attached, double bond O. This is a O minus. Sorry, this is extra. Okay. So this O minus will take proton from this OH, and now you will gonna find something like this. Now this is your final product, Me. This is your Cn. Okay, this is your final product of this reaction, Okay, so I have told you all the steps mechanism in very much detail, like the reason behind every step. Okay, I hope this is all clear to all of you. Okay, now we are moving to next question. Okay, fine. Now see, I have taken something like this. Okay, the question is, yeah, see, I am taking all the questions from the organic chemistry. Okay, organic chemistry, Clayden, chapter number 6, nucleophilic addition to carbonyl group. You can match, you can refer that book. Okay, so now I am taking different question from Clayden, from chapter number 6. Here we have pH, here we have OH, here we have Me, and here we have cyanide. And I am taking the reagent here HCl, H2O. Right. So now the question is, what we will get product. Okay. So how to proceed this reaction? So first of all, you have to think about the reagent. The reagent we have taken here is a HCl. So we have to find a product. Okay. So we have taken the reagent here HCl because and you know that and you all know this, HCl is acidic. So that's why here is an acidic condition, and we have H2O here we have taken. Okay. So what happened? So first of all, the first step. See, first step, what happened? The nitrogen. Here we have pH, here we have OH, here we have Me, here we have cyanide, right? And the nitrogen have a lone pair. So because there is an acidic condition, we have H plus in the solution. So that's why this nitrogen lone pair will take this proton. Okay, I hope this is clear. This is very basic thing. So now pH, OH, this is Me, and this is cyanide, and now you will get a nitrogen, you will get a positive charge. Okay, so please like, share and subscribe this channel. Okay, so thank you so much for joining the session, but still some questions are left. Only 2 questions are left. Okay, and then after we will end this session. Okay, so please take a patience. Okay. Okay, so yeah, so because there is an acidic condition in the reaction, so that's why this nitrogen lone pair is acting as a base, and this nitrogen lone pair will take proton from this solution because we have acidic condition. And now after taking the proton, the nitrogen got a negative charge. Now what happened? See, pH, here is the OH, here is the Me, here we have C triple bond N, here we have positive charge. So now see, now you already know that the C triple bond N is a polar bond. Okay, it is a polar bond. Why it's a polar bond? Because due to electronegativity difference between this carbon and this nitrogen. So that's why this carbon got a delta positive and this nitrogen will got a delta negative. So that's why this C triple bond N will work as a electrophilic center. Electrophilic center. I know this is very basic, but still I have to tell you this all. Okay. So this is the electrophilic center, right? Now what happened? See. So that's why we have taken here H2O also in the solution. So now the actual mechanism is something like this. Amy, here is a C triple bond N, here we have H, here is a positive charge, and now because carbon is acting as an electrophile here, so that's why H2O will come and attack at this electrophilic center at this C triple bond N. And now after attacking the center, the pi bond of this bond will gonna shift on the nitrogen as a negative charge. So you will get something like this. If you have any doubt, you can ask in the chat box. Okay. So there we got nitrogen, something like this, and we have here H2O, and because oxygen has a 3 bonds, so that's why there will be a positive charge on the oxygen. Now what happened? See. Now what happened? Because oxygen got a positive charge here, so we have to make a neutralize. So how can we neutralize this positive charge? Because we know that the positive charge on the oxygen is unstable, so that's why this nitrogen lone pair is acting as a base, and it will take proton from this. It will take this proton, and after taking this proton, this bond will gonna break as a negative charge on the oxygen. And now you will got a neutral molecule. Now you will got a oxygen as a neutral. So you will find something like this. pH, here is the OH, here is the Me, and here you have C double bond N, here you have H, again H. So that's why nitrogen has a 4 bond, so it will get a positive charge. And now here we have OH here. Here is a OH. Now what happened? See. Now what happened? See. So because now the nitrogen got a negative. Now the nitrogen gets a positive charge. So now what happened? This lone pair will gonna delocalize, and this double bond will gonna shift on the nitrogen as a negative charge. Now you will find something like this. Here is the Me, here is the carbon, and here you have NH2, double bond O here. Here is a positive charge on the oxygen. Now what happened? Because still we have there is a positive charge on the oxygen, so that's why this is unstable. So what we have to do? Now this NH2 lone pair will act as a base, and it will take intramolecularly proton from this proton. Okay. Now this bond will gonna break and it goes on the oxygen as a negative charge. Now you will find something like this. pH, OH here. Here is the Me, right? And here you will get something like this. NH3 positive charge here, and here you got something like this. Okay. Now what happened, because in the starting we have taken H2O also in the solution, so that's why now the H2O will come as a nucleophile, will work as a nucleophile and attack at the electrophilic center. This carbonyl center is working as an electrophilic center, so that's why this H2O will attack on this carbonyl center, and now this double bond will gonna shift on this oxygen. Okay, so you will get something like this. Here is the OH, here is the Me, here is the carbon, here is the O negative, and here is the NH3 positive. And we know that because NH now there is a positive charge on the nitrogen, so it wants to leave because it is unstable. Okay, so we have here something like this. OH2, here is a positive charge here. Okay, so now what happened? So this negative charge will take proton from this H2O plus, and now you will get something like this. pH, here is the OH here, and here Me, here carbon, here is the NH3 plus, and here we have OH, and here we have also which. Okay. Now what happened? Because you know that you know this. I think on the one carbon there is a two hydroxyl group is not a stable, so that's why what happened, the one oxygen lone pair will gonna come back, and then this NH3 plus will be leave as in the neutral form as a NH3. Now you will get a product something like this. C double bond to H. This is our final product of this reaction. Okay, this is our final product of this reaction, right? So this is basically hydrolysis of cyanide in the acidic medium. Okay, this is basically hydrolysis of cyanide in the acidic medium, right? So this is the mechanism of this hydrolysis of cyanide in the in the acidic medium. Okay, so you will get so the cyanide will change in the carboxylic acid. Okay, so this is basically hydrolysis reaction of the cyanide, right? Now I am taking some different question. Okay, I think this will be the last question, okay, of this chapter. Then we will end this session. Okay, see, we have something like this, something like this. Okay, yeah, here is a OH, here is a OH, okay, and I have taken here LiLH4. So this is the, so what happened now? See, so first of all, make a proper structure so that C triple bond N here, and if you draw the structure of a LiLH4, then you will find something like this. Here is a negative charge, okay, and here is the Li positive. It's the counter ion. Okay, fine. So now what happened? This H minus will gonna attack. Okay, but before this attack, so what happened now? See, what happened now? This H will be gonna attack as a hydride, as a H minus at this electrophilic center, C triple bond N. Okay. Now this bond will gonna shift on this cyanide or this nitrogen as a negative charge. So now you will get something like this. Here is a C double bond. Okay, negative charge here, and here you have H. And because you know that we have AlH3 now, AlH3, and because we also know aluminum has a vacant orbital, so that's why this negative charge will coordinate with aluminum. Okay, and now you will find something like this. You will find something like this. Here is the OH, C double bond N, here is the aluminum, here is the H, here is the H, here is the H, and aluminum got a negative charge. Now what happens? See, because now again the hydride will attack, because aluminum has 3 hydrides still left, so that's why again the hydride will gonna attack at this electrophilic center. Okay, at this electrophilic center. Now the nitrogen got a negative charge. So you will find something like this. Here is the OH, here is the carbon, here is the negative charge, and here you have aluminum AlH2. Right? Now what happens? See, because so now we have taken H2O to do the workup, right? To do the workup, we have taken here H2O, and this nitrogen anion will take proton from this H2O, and now it becomes something like this. NH, this is our AlH2, okay, and this is CH2, right? Now what happened? See, now again we have to do workup, because still it's a negatively charged species, so we have to again work up. So we have to do again workup here. Okay, so how can we do this? See here we have OH, right, carbon, H2, we have taken here H2O to do the workup. Okay, so now this is the nitrogen, hydrogen, right? So this is basically lone pair here, and AlH2. Now we have H2O. So what happened? So this will take proton, right? This will take proton from H2O, and now you will find something like this. OH, CH2, and here you got NH2, right? Okay, and after that, because aluminum has only AlH2 here, okay, yeah. So now this OH minus will attack on this aluminum, right? So it will become AlH2OH, right? But this is our final product. It means we have reduced the cyanide into CH2 into amine. Okay, so this is basically a reduction reaction. This cyanide reduction with AlNH4. Okay, cyanide reduction with AlNH4, right? So this is the general mechanism of this reaction, and this is the last question of this chapter number 6 of the organic Clayden reaction, right? So I hope you all have understood very clearly. I have tried my best to tell you all the things. So now from my side, the chapter number 6 of the Clayden is completed. The whole questions I have done. Okay. Any doubt you can ask in the comment box. I will try to answer. So this is basically a reduction reaction. Cyanide, so here is the cyanide, is getting reduced to CH2 NH2, right? So that's all about the chapter number 6. I hope you all have enjoyed this live session, and thank you so much to all of you who have joined this session. Okay, so please like, share and subscribe this channel, Chemistry Portal. We will talk only about organic chemistry on this channel, like reaction mechanism. Okay, and yes, simultaneously I have started a name reaction series also. Till now I have done 31 name reaction series alphabetically on my YouTube channel, already uploaded. So you can go and check the playlist, you can find there. Okay, so this is all about the today class. So if you ask, so if you need this this PDF, I can give this PDF in this description box. You can go and check so that you can understand very clearly. Okay, so that's all about this chapter number 6. I hope you all have enjoyed today. From my side, finally, the chapter number 06, nucleophilic addition to the carbonyl group, is completed. I have done all the reactions from chapter number 6 from my side. Okay, I have done all the mechanism step by step, and I have tried my best to give you the reason behind the mechanism, like why this is happening, why this is not happening. Okay, okay, fine. So I think we should have to close now. Yeah, so please like, share and subscribe our channel to get a more feel of organic chemistry. Okay, so today we have done a lots of things. Yeah, lots of things. Okay, so fine. So bye bye. So take care. Tata. Bye bye. See you soon in the next episode series of Clayden series. So तब तक के लिए good night. Take care.